Hello my friends, and welcome to the 10th class in this series into which, my friends, we are going to answer the 10th question of the 2024 British Pearson Edexcel International IGCSE. The subject is chemistry. Today, my friends, as we said, we're going to start with question number 10. Question number 10, my friends, is about decomposition. This is the question for the decomposition of hydrogen peroxide. Before we start answering the question, my friends, let's take a very quick and brief review about decomposition. So what do we mean by decomposition? Decomposition, my friends, is a reaction into which one chemical material, we have one chemical material or one compound is disassembled into two or more elements or compounds. Let's look at the reaction here. We have this equation, hydrogen peroxide, one chemical material. This chemical material is disassembled into water and oxygen. This is a compound, and this is an element. So how do I know that this is a decomposition reaction? I know because on the reactant side, here the reactant side, I have only one chemical material. I have one chemical material, which is the H2O, and on the other side I have more than one chemical material. So I can say that this chemical material was disassembled into more than one chemical material, and the reaction is decomposition. The question is, the rate of reaction increases when a catalyst of manganese 4 oxide is added. Let's try, my friends, to use the information we have learned in the previous class to get the formula of manganese 4 oxide. So we have manganese here, Mn. This is manganese. 4 means plus 4. Oxide is oxygen, because we said ox means oxygen. This here, refers to the fact that oxygen is minus negative ion that is attached to any positive ion except for hydrogen, not hydrogen, because if it's with hydrogen, it makes water. So how can I make this chemical compound? A lot of students would make this mistake. They say, teacher, you taught me that if the numbers are always positive ion left, negative ion right. This is correct. Now, in the second step, we look at the numbers. This is 4 and this is 2. So that I should what? I should cross these numbers. So the chemical material should be Mn2O4. Well, this is half correct, because generally, my friends, we need the simplest formula. We need the simplest formula. How do I get the simplest formula? I divide both of them on 2. Why do I have to divide both of them over 2? Because I need to make one of them 1. So the formula will become here MnO2. I divide this 2 with 2, and 4 over 2 is 2, so that we get this number here. So what is the chemical formula of manganese 4 oxide? The chemical formula is MnO2, as we see here. Now, let's answer the question. Describe how a catalyst increases the rate of reaction. So here the question is theoretical. We say a catalyst provides alternative pathway for the reaction which has lower activation energy. Those are the terminology which are important. So alternative pathways for reaction and this pathway has lower activation energy. Now, second question, as you see here, a student adds 50 cubic centimeters of hydrogen peroxide. So hydrogen peroxide is solution. So it is what? Solution means liquid. So the liquid material here inside this container is hydrogen peroxide to a glass container, and then add 1.0 gram of manganese oxide. So the manganese oxide here is solid material, and this solid is unsoluble, because if it's soluble it would be dissolved, and it is solid here, it doesn't dissolve. Now my friends, what is the question? The question is, name the glass container. What is the name of this glass container here? What is the name of the glass container? Generally, my friends, it's called conical flask. Conical flask. Some people like to call it Erlenmeyer. Erlenmeyer is a German word or a German terminology, nomenclature for this apparatus, but generally in English we call it conical flask. So the word Erlenmeyer is not accepted in the IGCSE. We need to take the conical flask. Now let's answer the next question here. The student waits until the hydrogen peroxide solution completely decomposes, means the reaction is finished. Describe how the student could then show that manganese 4 oxide was only a catalyst, not a reactant. What do we mean first by the word catalyst? In here, my friends, we need to understand the terminology catalyst. So what is a catalyst? If we want to prove that MnO2 is a catalyst, we need to understand the word catalyst. A catalyst, my friends, is a chemical material that is used to make the reaction fast, but here, this is the but, wait for the but it doesn't react. So if we have a chemical reaction like this, decomposition of H2O2 to make H2O plus oxygen, as we say here, plus oxygen, and we add MnO2, 1 gram of MnO2 as a catalyst, we wait until the reaction finishes, and what do we do at the end of the reaction? Here, my friends, we filter out the manganese 4 oxide. What do we mean by filtration? Filtration, if you remember, my friends, is a physical process. If you remember in question 4, I think we talked about it. Physical process into which we separate an insoluble solid matter from a liquid. So we had a filtration. We filtrate what? We filtrate manganese 4 oxide. What do we do? So what do we do, my friends, here? We take this conical flask, we pour it over the funnel, which contains the filtration paper. The liquid will be coming down here as the drops, and the solid, which is MnO2, will be what? Will be stuck here. So we take this manganese and manganese O2 and we reweigh it again. Here, we wash it and allow it to dry, then reweigh the catalyst. The mass should remain exactly as it was 1 gram. So if I take if I filtrate, I isolate this MnO2 again, and I reweigh it. Before the reaction, it was 1 gram. And if after the reaction it is 1 gram, we say that it is a catalyst because it didn't react, or it hasn't reacted, and it stayed with the same mass, as you see here, my friends. Now, my friends, let's go to question 11. Question 11 needs a little bit of concentration, so let's pay attention for it. This question generally, my friends, about carbon structures. As you know, some elements like carbon, my friends, they have different structures depend on pressure and temperature. For example, if you bring a piece of carbon, which is coal, and put it under high pressure and high temperature, this piece of coal or this piece of carbon is going to be like a diamond. So, my friends, we understand that a diamond is originally carbon, but it was put under high pressure and high temperature, and it has this 3D structure. In this structure, my friend, each one carbon is attached to 4 carbons. 1, here, 1, 2, 3, 4. So that it is strong structure. While graphite, my friends, wasn't put under a very high structure or high pressure, so that it has this structure which is a little bit weak, and it is layers. Each layer is over the other. So those are layers. So the question is, give a reason why diamond is an element. Generally, my friends, diamond is an element because an element is made up of 1 types of atoms. For example, Fe is an element, Cu is an element, calcium is an element, oxygen, O2 is an element, because the atoms here, the atoms are similar, but we have CO2, for example. This is compound. Why is it compound? Because we have 2 or more different types of atoms inside one molecule. We have, for example, H2SO4. This is also what? This is also a compound. So why is diamond an element? Because it is made up of 1 type of atoms, and it is only carbon. Describe the forces of attraction in covalent bond. First of all, my friends, we have to understand what do we mean by covalent bonds. Generally, my friends, covalent bonds are made when 2 atoms decide to share their electrons with one another. For example, as you see here, my friends, here we have this atom has electrons here, and it put 1 of them here. The other atom has also electrons, those are electrons, and it decides to put 1 here to share. So this pair, we call it shared pair, the shared pair of electrons is going to be attracted to both. This is the nucleus of the first atom, this is the nucleus of second atom. So this will be attracted by both nuclei. So what is a covalent bond force of attraction? Attraction between shared pair of electrons, which is this, and the nuclei, this nucleus and this nucleus. So each atom provides one electron to share, and each nuclei of the nucleus of the atom is going to attract it towards it. That's why we have something called the covalent bond. Explain why graphite conducts electricity. This is easy. Generally, my friends, graphite conducts electricities because it has delocalized electrons that can move freely through the structure. So the electrons here, the electrons, this atom, carbon, has electrons. This has electrons. This has electrons. This has electrons. Those electrons here, my friends, are free to move. They can move from this layer to this layer to this layer so that they can conduct electricity. While diamond doesn't conduct electricity. Why? Because generally, my friends, the electrons here and electrons here, they cannot move. And they are not delocalized. So here each atom prevents its electrons from moving. That's why diamond doesn't conduct electricity, because it doesn't have delocalized electrons which are free to move, while graphite has this type of electrons. Now, my friends, let's move to next question. Explain why diamond is hard while graphite is soft. First of all, my friend, we need to understand what? The structure. So what is the structure of each one of them? Let's start with diamond. Diamond is hard because it has rigid, means strong, 3D lattice. What do we mean by a 3D lattice? Look here, my friends, at diamond. Diamond has X here. It is related with or connected, bonded with an atom on X, on Y, and on Z. That's why we call this chemical compound a 3D lattice. This has 3D lattice. And the bonds here, my friends, where every carbon is bonded with 4 others. So we have 4 carbons here. 1, 2, 3, 4 carbons, my friends. 4 carbons are bonding with this carbon. So breaking the bonds is nearly impossible because we have, number 1, 4 bonds. Number 2, these bonds are 3D in their structure, so breaking them is very difficult. It needs a lot of energy. That's why diamond is very hard. While graphite is soft because it has layer that can easily slide over one another. You see, this is layer and this is layer. If you press on carbon, if you have a piece of carbon and you press on it, you're going to see that it will be cracked into 2 pieces. Why? Because the layers here are separated from one another, while carbon here are very connected with one another. Now, last question here, my friends. Another form of carbon has molecules with the formula CX. Now, we talked about the formula of diamond. Each diamond is C5. What do we mean by C5? Means one molecule has 5 carbon. Here, as you see, my friends, we are going to talk about what? We're going to talk about CX, a new formula. Another form of carbon has the molecules with formula CX. We don't know how many carbon in this formula. We don't know 1 carbon to how many carbons it is attached. X carbons. Now, X represents the number of carbons that one atom is attached to inside this molecule. Now, one molecule contains 6.02 multiplied 10 exponent 23 molecules. This is, as we all know, if we remember, this is called Avogadro. Here, Avogadro constant. And we all know Avogadro constant. In here, my friends, the question is, calculate MR. Calculate MR. Then calculate X of C. First of all, to calculate MR, we need to understand what MR means. So what is MR? MR is the mass of 1 mole, which is 6.02 multiplied 10 over 23 molecules. So we know here, my friends, we know the mass, we know here the mass of one molecule here, the mass of one molecule. The mass of one molecule is 1.4 multiplied 10 exponent minus 21. So do we need the mass of one molecule only? No, we need the mass of 1 mole of the molecule. Okay, the 1 mole of molecule, how many 1 mole of molecules, how many molecules is it? As they say here, each 1 mole of CX contains this number of molecules. So the mass of this number of molecules is MR in gram. How to calculate it? We say each 1 molecule has this mass. If we have 1 mole of these molecules, what is its mass? The mass is cross multiplication. We have to multiply this number with this number, then we divide them over 1. So the mass, MR, which is gram over mole. So it is the mass gram for 1 mole. So the mass of 1 mole of this molecule is 842.8 gram per mole. So now we solved the first problem. We could calculate the mass of 1 mole or 6.2 multiplied 10 exponent 23 molecules. Now, this, what is this now? Now, my friends, what do we have here? We have, as we see, MR, which is the mass of 1 mole of CX. Now, my friends, if I tell you that each 1 mole of C1, 1 carbon, each 1 carbon is 12 grams per mole. So what is X for which we have 842.8? The question is like you ask a child, you tell this child that each 1 bag of chips, each 1 bag of chips means 1 carbon atom. Here, 1 is equal 12 grams. If we have 842.8 grams, how many, here, X, how many carbons or let's say chips bags can they make? We say that here each 1 mole, as you see my friends here, each 1 mole is 12 grams. How many atoms? 1 atom makes 12 grams. How many atoms can make 842? We have to divide them over 12, and this is 70 atoms. So X is 70, as we see here, my friends. And the molecular mass is 842.8 gram per mole. Till here, my friends, we have answered all questions. If you have any questions, please do not hesitate to get in touch with me. In the next class, my friends, we are going to go through question number 12. Till that time, my friends, I wish you all the best. Study hard, and if you have any questions, do not hesitate to get in touch with me.